Explain like I'm 5, blockchain and cryptocurrency, part 2. All right, so in the previous video, what we did was we talked about the terms blockchain and cryptocurrency, but in conjunction with a couple other terms, peer-to-peer networks and decentralized ledger technology. And the goal of the last video was to help those of you who are unfamiliar with this stuff, unfamiliar with what's kind of going on with blockchain and cryptocurrency, to better understand like the inner workings of these things together, to help you guys build a mental model of kind of like what's going on and how everything kind of works together. And so the best way to think about this, as stated in the previous video, is to think of these things as working together to form a larger entity, an entity that we will call a world computer. I highly suggest watching the previous video about this because it will go into a lot of detail about how world computers work, what they are going to offer, and kind of give you a really better idea of, the importance of them in terms of not looking just at the financial aspects of cryptocurrency, but more so their role in terms of how they allow this larger entity that I'll refer to as a world computer to work. But for those of you who haven't seen that video, I'll do just a quick overview. What do I mean by a world computer? Something that is publicly run and publicly accessible. Something that is decentralized, meaning that it does not exist in a singular place. It is comprised of lots of computers all over the world that kind of come together to create this entity as an aggregate of them together. It is irrepressible, meaning it cannot be shut down. Because it's decentralized, it therefore transcends government, corporate, regional control, and so no one really owns it. So it's kind of, no one can like shut it down. It's immutable. It is trustless, meaning you don't have to worry about trusting the computer to do the right thing. Not trustless in the sense that there is no trust, it's that you don't have to worry about trust. It's encrypted and highly secure, and it is financially self-sufficient. And to kind of explain what I mean by that, because nobody owns the world computer, how does it pay for itself, right? It has to kind of have its own economy, so to speak. And cryptocurrency plays a big role in that, as it is not just what incentivizes people to support the world computer, but it is also how transactions get made through the world computer. And just to recap the analogy that I provided and how this works, a good way to think about this kind of in a physical sense is to imagine a bunch of people standing around a circular tarp or like a parachute. And these people are from all over the world. You have Raja from Russia, Sven from Sweden, Bella from Belgium, Saeed from Saudi Arabia, Nasher from Nigeria, Indra from India, and Maria from Mexico. And so when they stand around this circular tarp and they grab a hold of it and pull it towards themselves, it becomes taut like a platform, allowing things to kind of exist on top of it. It's important to understand that without people holding on to it there to support it, it would not exist at all. So now I'm going to fast forward, into that analogy and kind of skip ahead on some details. But basically, those that are holding onto the tarp will have like their own little kind of pockets in the tarp that they can keep red balls or maybe poker chips or some sort of like, entity that represents a unit. Further, they all have their own copy of photo records of the TARP activity that kind of go in chronological order, and they all kind of keep track of things using these photo records. And whenever there's any kind of activity on the TARP, such as the exchange of these balls from one entity to another, they follow a protocol where one of the people gets chosen to go first to identify those changes. In this case, we'll say that it's Raja. Raja says, "Hey, I saw X, Y, and Z happen. These people have this many red balls. By the way, my prior records indicate X, Y, and Z." And if everyone else agrees with Raja, then another photo gets taken of the TARP, which gets added to everyone else's chronological list of photos that they have. And Raja gets a reward for going first and having everybody agree with him. And so what this breaks down to is that these red balls represent cryptocurrency. The pockets in the TARP represent cryptocurrency wallets, or just wallets. The TARP itself represents a decentralized ledger. The people holding onto the TARP represent a peer-to-peer network. And the photo strip records represents blockchain. Blockchain is nothing more than a data storage mechanism that kind of stores things in chronological order and blocks, like little capsules of information. But together, they kind of form this system. So the first thing we have to do here is kind of swap out the people for computers, and the peer-to-peer network that the computers create, when they all connect to each other, allows for this virtual decentralized ledger to exist. It's something that doesn't exist physically per se, but for the sake of this analogy, kind of think of it as like this invisible platform or something that kind of exists between the computers that exist all over the world. Cryptocurrency goes into wallets. Wallets get kept track of by a decentralized ledger. The decentralized ledger is supported by the peer-to-peer network, and all of the computers in the peer-to-peer network use blockchain to keep track of all the activity. And the incentivizing mechanism for the computers to be doing this in the first place is that they get rewarded with cryptocurrency. And so that was kind of the main point of the previous video, is to help you guys understand that together, blockchain, cryptocurrency, peer-to-peer networks, and decentralized ledgers, they work together to create this world computer. And this is a term that isn't necessarily widely used, but I think it's an easier way to think about it. It's basically this kind of entity that can keep track of information and doesn't require any kind of funds to keep it up and running. It incentivizes people to come together to allow it to exist in the first place, and therefore provides almost like a free service to the world. I wouldn't say exactly free, but just a service that isn't controlled by like a government or a corporation. Anybody can use it to keep track of information. Right now, world computers are still getting more and more powerful. If you can think about like the first computers that ever existed out there, decades and decades ago, they really couldn't do much more than keep track of, a value, do some calculations. And that's, kind of a comparable thing to the first world computers that can really just keep track of values and calculations. And therefore, those values are cryptocurrency. But world computers are getting more and more powerful in terms of what they allow to happen. And we'll be getting into that in this video. The other thing that I just want to say is, like, when you hear the term blockchain, a lot of times people are referring to this larger system of things. Not all the time, but for the most part, they are referring to that. Because blockchain by itself, again, is just a data storage mechanism. But when paired with these other entities into like a unit, it creates something bigger. So the first thing I want to do is kind of talk about types of blockchain. And really, there's two main flavors of these blockchain systems. I think there's a better way of looking at it. It's a blockchain system or like a world computer. There is permissionless and there is permissioned. And a permissionless blockchain system, anybody can roll up and take hold of that TARP and help support it and participate in that kind of game that was more elaborately discussed in the previous video about how you help keep track of all the information on the TARP. When everyone agrees with you, you get a reward and the process continues. So in a permissionless system, anybody can kind of roll up to the TARP and take part of that. However, a permissioned system does not allow that. You have to be granted access to come and do that. And so that's something that if a institution of some sort were to adopt this kind of system, they perhaps would not let anybody become a node in that peer-to-peer network that's like running everything. And so this is where the concept of like maybe the term world computer can break down, because in a permission system, it isn't necessarily something that is free to anyone to kind of partake in. It could be something that's then adopted by an entity or a government, and where particular people or nodes are chosen to keep things supported. And so when I talk about world computers, I'm talking about permissionless systems, and those are the ones that personally I'm the most fascinated with. It doesn't mean that permission systems aren't also really cool from a technological standpoint, just from like this idea of having something that's free to everybody and not owned by anybody. Permission systems kind of like fall out of that category. All right, so the role of blockchain. And so here we're going to get into kind of like where world computers are going. So again, let's think about this not so much from the permissioned blockchain system, but from the permissionless blockchain systems, where we are able to generate a world computer that anybody can access, anybody can help support, and what its role will be in terms of how we use it as a society. I use a lot of visuals to explain things, and again, this is a explain like I'm five breakdown of things, and so I'm using analogies, I'm using oversimplifications to explain things, and so I know that there are developers out there that could be watching this and their minds are exploding because of the lack of detail I might be going into from a technical standpoint to explain things. But for the average person, I think that this is a good way to kind of visualize what's going on so that you can kind of make sense of its importance. So imagine this blockchain system that we've talked about or discussed a little bit in this video, but more so in the previous video. Basically, it's just a system that can keep track of information, and that's at the bottom level there. The blockchain system, this is just like this aggregate of computers that come together to keep track of information. And the first thing that they really have been able to kind of keep track of is a value that we call cryptocurrency. And so anything that happens with the cryptocurrency gets kept track of by that underlying blockchain system. However, as these things have started to evolve, you can kind of think of like this underlying framework becoming more powerful. Things are getting built on top of it. It's evolving. And the next kind of step of its evolution is to take the concept of a cryptocurrency and extend it a bit farther into something that we will call tokens. And there's a lot of different kinds of tokens out there, and the terminology and kind of way that tokens and cryptocurrency or crypto assets gets defined is still getting molded, it's still changing. But the idea here is that tokens can represent other things outside of just a value. Where cryptocurrency is like a unit of like value, a token could represent something else. The next layer on top of that is something called smart contracts, which again, I'm oversimplifying this, but think of it kind of as like, if X, then Y statements. If something happens, then this happens afterwards. And so you can have lots of smart contracts that also get kept track of by the underlying blockchain system. And the variables that these contracts deal with pertain to the cryptocurrency, they pertain to tokens, and they can also, are starting to pertain to like external input. I don't want to go into too much detail about this, but there's this concept of like an oracle, which is a way to pull information from the outside world into the smart contract to help execute something. So you could say if something happens, in the outside world, then Y gets executed. And so an example of that could be, I'm going to hold off on that. I'll give you an example momentarily. Let me finish explaining this here first. And so then at the top level of all this is something that we will call dApps, decentralized applications. And I guess the easiest way to explain a dApp is that think of it as the interface that a user would interact with in order to access these smart contracts or anything else kind of below it, right? So we talked about wallets in the previous video to a certain degree. In a way, a wallet could be a dApp, though I think that it's a very primitive kind of dApp, and the kinds of dApps that we'll be seeing coming, over time in the future will become far more complex. But essentially think of a dApp as like an interface, and this is something that could be built with like your typical HTML, CSS, or JavaScript, or really any other kind of like programming language. The main thing is that it is connected to a different backend. The backend here, the information that it talks to is the blockchain system, and is interacting with all these things that the blockchain system is keeping track of. And if you remember from our previous video, I talked about how the current internet can be thought of as like a centralized system where all of your devices, when you open up an application, it's talking to a backend that we can think of as like the cloud, right? In this situation, the blockchain system is replacing the cloud. Hopefully that makes sense. So instead of having some sort of very large storage facility, just think of it as a big computer that a company owns, where they store all of your information and you access that information through your device. Instead, all of that information is stored on a blockchain system, a decentralized blockchain system, or a world computer. And it stores your information and you access it through your device as normal, but this time you have to kind of go through using a dApp that connects to it. So we're going to come back to that in a few minutes. I'm going to explain a few other things for you before we do that, starting with types of consensus. And so consensus, if you remember from the previous video, is basically the term used to refer to when the computers or the nodes in a peer-to-peer network come to an agreement on the status of that TARP, or what the status of the decentralized ledger. It's when, you know, a computer goes first, it says, hey, these are the changes that have occurred. All the computers say, yeah, that we agree. And when they all agree, a new block gets generated. So there are two main flavors of consensus out there. There is something called proof of work, and then something called proof of stake. And there are variations of these as well, but from a high level, they kind of have two, they can be delineated in terms of their primary differences. We'll start with proof of work, and by the way, Bitcoin operates via proof of work. And this is a way that you can kind of think about how proof of work works. Think of every computer in the peer-to-peer network having a Boggle set. And I'll explain a Boggle set in a moment for those of you who don't know what that is. But what this really is going to get into is how a computer gets chosen to go first. Because the reality is, it isn't exactly just randomized. It can be maybe more so when we get to proof of stake. But with proof of work, computers kind of compete for the right to go first. And they do so by trying to solve a cryptographic puzzle. And so a good way to think of this, kind of like using an analogy, is that each computer has a Boggle set. And a Boggle set is a tray of dice that have letters on it. And the purpose of the game is that you shake the tray, you get letters, and you try to make words out of those letters. But in this case, think of it like the computers are shaking the tray and they're all trying to get all A's across the top. This is something that is very hard to do, but it's very easy to verify. So though these computers are not in proximity to one another, they could be all over the world. Let's think about the analogy that we talked about earlier and in the previous video, where you have people holding onto a tarp, and they can kind of look across the tarp to see what the other person has got. So everyone's shaking their Boggle tray to see who gets all A's first. Something very hard to do, but as soon as somebody gets it, it's very easy for the other people holding onto the tarp to look across and be like, yep, they got it. Right? So this is a way that the computers compete in a proof of work kind of system in order to go first. And so they shake. The first one that gets all A's gets to go first. In a proof of stake system, it's a little bit different. Instead of having to compete to solve a cryptographic puzzle, think of it more of like a raffle system, where in the middle of the tarp, again, this is figurative, it's an analogy, right? This doesn't physically exist per se, but kind of think of it like there's a raffle system where every coin that one of these nodes has in its wallet, there is a corresponding ticket in a fishbowl in the middle. And when it comes time to choose who gets to go first, it's drawn out of that fishbowl, and if it matches one of those nodes' coins, they're the ones that get to go first. Again, this isn't the exact way that it happens, but it's an easy way to kind of think about it. It's more about the amount of coins that you have inside of your wallet. They give you more chances to be drawn to go first. Whereas with proof of work, it's more about your ability to do a cryptographic puzzle. So there are some big differences between these two things in terms of I guess you could put it as like their how do you say it? Their barrier to entry, I guess is the best way to kind of say it. When it comes to proof of work, again, it's about solving a cryptographic puzzle, but the problem with that is you have to have a lot of computational power to do that, right? You have to have a computer that's very fast and very powerful in order to shake that boggle tray a lot in order to get all A's, because you want to shake it as many times as you can, as fast as you can, because it gives you a higher chance of basically getting all A's. And so you have to be able to, if you wanted to take part in this, if you want to basically get involved with Bitcoin, you would have to get a machine, a computer, and at this point, it's gotten to the point where you have to have specialized equipment. That costs a lot of money. But there's almost an economic principle to that if you think about it. Whereas like if Bitcoin has value, what else out there has value? Gold has value. Diamonds have value, right? And it takes work to get those things. If you want to mine for gold or you want to mine for diamonds, you have to buy equipment. You have to put in the work to get it. And so there's some sort of like kind of economic principle behind that that drives it. So instead of having to go, stick dynamite down in a hole and blow up, rock to get to the gold or the diamonds, instead what you have to do is solve a cryptographic puzzle. That's how you show your proof of work, that you're willing to put in the time and effort to get to the reward. However, this computational power requires a lot of energy, and so that's a problem that has been addressed or talked about in the community of all of this. Is that this drains a lot of electricity. You have to be able to find cost-effective systems. What if the price of electricity goes up and it's no longer profitable to be running these computers in order to mine for Bitcoin? And by the way, mining is the term used for the generation of new Bitcoin or cryptocurrency that operates under a proof of work system. You are mining for it. Again, going back to that analogy of like you're mining for gold or you're mining for diamonds, it takes work to do it, and therefore you have to put in energy and resources to be able to access that stuff. However, with proof of stake, it's a little bit different. Instead of having a cryptographic puzzle that you have to solve, it's more of a raffle system, and you enter in it by having tokens of your own, having your own cryptocurrency in a wallet. So you hold on to cryptocurrency in your wallet, and that's called staking. You are putting these up for stake, and if your token or your cryptocurrency matches the raffle ticket chosen, then you get to go first. That's a kind of a way to think about it. However, there's a lot of nuances to how that actually goes down, and there are things that are kind of put in place to help prevent the situation of those who have the most get to go first more often, right? If you have more, you would have higher chances of going first more often and therefore getting more reward. And so that that can be something that's argued about the downside of proof of stake. There are other things that go into that, like there's other variations of proof of stake, I should say. One is called delegated proof of stake. I don't want to get into too much about that, but now that I'm thinking about it, maybe we'll talk about it. And what happens there is that not everybody gets to come up to the table or to the tarp and stake their cryptocurrency in order to get rewards. Only those that are either kind of chosen as delegates, right, get to do it. And those who are not chosen as delegates use their cryptocurrency as votes for their delegate. So you basically think of it as, in government you have an entity, Parliament, Congress, the Senate. I'm sure there's lots of other ones that I'm not thinking about from different countries at the moment. But you guys get the idea. In a democratic situation, you have people that represent you, and they're the ones that go to the table, and they're the ones that can earn the rewards. However, by voting for them, if your delegate wins, it will divvy up its rewards with its constituents, those who have voted for it. So in a proof of stake or a delegated proof of stake system, it's a similar situation, except you have delegates that sit at the table, and those who vote for the delegates by staking their coins as votes get kind of kickbacks from the delegates as they win rewards. This requires much less energy. Anybody can do this with any computer. So it really caters to the average person being able to get involved with this. And I think that's an important thing when it comes to the concept of a world computer where anybody is able to access it and anybody is able to partake in it. And that's my personal opinion about it. But again, if you want to create an entity that is egalitarian in nature, allows anybody, equal chance, you've got to make it so that it has an easier barrier to entry. And instead of having to purchase lots of expensive equipment in order to mine cryptocurrency, proof of stake systems make it so that all you have to do is have a computer and some cryptocurrency in it, in your wallet in order to partake. And usually this is called staking, but it can also be referred to as minting or forging in terms of the creation of new cryptocurrency in a proof of stake system. So those are your two flavors of types of consensus, proof of work and proof of stake. Hopefully that gives you a high level understanding of the differences between the two. The next thing I want to talk about is types of cryptocurrency. And this is something that could be talked about in entirely, it's in its own video, and there's lots of detail, lots of nuances, but I'm going to try to break it down into some very simple categories for you. Again, this is an Explain It Like I'm 5 video, so I'm just trying to cover some very high level things. And so what I want to talk about are kind of three types of crypto assets. We've talked about cryptocurrency, we've talked about tokens, but we haven't talked about stable coins. We'll talk about cryptocurrency real quick. There's a lot of different cryptocurrency or cryptocurrency assets out there. I like the term crypto assets over cryptocurrency because I think as we see this stuff evolve, it won't so much be thought of as cryptocurrency, like currency. Currency kind of has a certain connotation to it. And as I talked about in my previous video, world computers are going to change the way we interact with value. It's going to change our definition of value, what we perceive as value. The same way the internet of today over the past 10 to 20 years has changed the way we interact with content. And so using a word that kind of pigeonholes things like currency, I see it as a little bit misleading. We'll see how it goes and what gets adopted in terms of the terminology. But think of things as crypto assets. But there's a lot of cryptocurrencies out there as crypto assets. There's Bitcoin, Bitcoin Cash, Litecoin, Ethereum, Dash, Pivx. Just to name some, these are just some of them. There's lots of them out there. There's no really rhyme or reason that I'm choosing these other than I think that they might be familiar to people who know a little bit about this. But there's some interesting properties to cryptocurrency as a financial unit that I think that we should nerd out on for just a little bit here. And that is, the first thing is that they are very easily divisible, meaning you can break them down into very small parts. So if you think about your currency wherever you live, I live in the United States. So I have the US dollar. If I lived in like South Africa, I would have the rand. If I lived in the UK, I would have the pound. If I lived in a country in Europe that dealt with the European Union, you would have the euro, right? You have these units of value, but you can think about them in terms of how much they can get broken down. The United States dollar, the smallest part of that is a penny, right? You can have a penny. We have a penny, we have a nickel, which is 5, we have a dime, which is 10, we have a quarter, which is 25. We do have 50-cent pieces. You don't really see them very often, and then you have a dollar. And then you have, we have $2 bills, but you don't see them very often. You got 5, you got your 10s, right? Basically, the way that we structure these values come in very specific kind of amounts. Whereas cryptocurrency can be broken down into a very small decimal. That's one of the beautiful things about having this in a digital way, is that you can really break things down into a smaller proportion. And that's going to become important when we start talking about tokens. But first we'll talk about stablecoins. Stablecoins are something that is a cryptocurrency or kind of a crypto asset that is tied to something else. It is backed by something else. Now, you see the term fiat up there. Fiat is a term for any country's kind of native currency. So the United States dollar is fiat, right? And interestingly enough, the United States dollar used to be backed by gold. And I think it was in the 1970s that we did away with that. So it used to be that you could buy a very specific amount of gold with a United States dollar. But as soon as that got removed, that kind of relationship changed. I don't want to use the word deteriorate because that sounds negative, and I'm not trying to make this a negative thing, some sort of like biased opinion about central banks or fiat or anything. But just think of it like it used to be, the US dollar used to kind of do what we are talking about now, which is that it's backed by something else. And so with stable coins, you can have cryptocurrencies that are backed by a specific thing. So for instance, you could have a cryptocurrency that is a stable coin that each one represents $1 US. And so you're probably wondering, oh, how does that work? How do you have that equate to that? Well, casinos kind of offer an interesting way to visualize that. By law, from at least what I understand, every chip on the casino floor has to be backed by a US dollar or a dollar in a vault underneath the casino, right? There has to be something that represents that. Anything that's on the floor has to be backed by an actual physical dollar, some sort of fiat. And so you can kind of think of cryptocurrency or stable coins like that. They don't exist in the physical world like a poker chip, but on one of these world computers, they can be thought of as like a virtual poker chip that is backed by like a US dollar or by the yen, right? So the entity that's kind of like, putting that together would have the fiat that backs those stable coins that they have kind of put into the system. They can also be backed by a commodity, like one stable coin could represent like $100 worth of gold or like $50 worth of silver. And further, you can have stable coins that represents are backed by cryptocurrency itself, other cryptocurrency. So you could create a stable coin. You might even get into the idea of this being a token at this point that is representative of an existing cryptocurrency. It will always reflect that value. It won't change. It's tied to that value. So, $100 worth of Bitcoin or $50 worth of Ethereum. And I'm saying $100 worth of Bitcoin, I laugh at myself because I'm doing another kind of exchange there where I'm saying Bitcoin, the value of Bitcoin is determined by the US dollar, whereas I think probably down the road, maybe that will stop being the case and we'll just start thinking of Bitcoin as the unit or some kind of, it might not be Bitcoin, it could be any cryptocurrency, but we'll just start thinking about that as the unit value. We won't be like, oh, it's worth this amount of US dollar. We'll just be like, that's the value. It's like one Bitcoin or, 0.0002 Bitcoin. We won't be tying it to a specific United States or other fiat value. Anyways, so that's the idea of stable coins, is that you have a crypto asset that gets kind of, it's in this world, this network of world computers that represents something else and holds that value at all times. So the last one that I want to talk about is tokens. And tokens are the most interesting because how these things kind of evolve is going to be really, really cool to watch. Because tokens can start to represent lots of different things, such as real estate, a car title, objects like art, licenses and access, stocks and securities. I mean, right now there's a lot of laws that are put in place, and again, I live in the United States, and so I'm more familiar with our laws, and the Securities and Exchange Commission, the SEC, regulates this kind of stuff and are currently, operating under laws that I believe were formed in the 1930s after the stock market crash that occurred here. And so, they're still kind of juggling to see how do they create new laws and new regulations and rules for how crypto assets can operate in terms of what they can reflect. Can they reflect stock? Can they reflect securities? But what makes them interesting if they start to do that, especially when it comes to the ownership of things, is that like cryptocurrencies that we talked about, they can be almost infinitely divisible. Meaning if you have a token that says, you say, represents like an object or a piece of art, lots of people could potentially buy into a part of that and own it amongst themselves. If it represented real estate, it would allow for people to invest in real estate that otherwise might not be able to, because I don't have all this money to buy a brand new house, right? But if we have a system where ownership of that house could be broken down into smaller parts easily, then it would make it so that people could invest in it by buying a small fraction of it, and then therefore, like, you know, however the system is kind of put together, they would earn profits off of that, allowing people to get into investments that they otherwise wouldn't be able to do by representing these things with tokens that can be broken down into smaller parts. Now, this is just a very small sample of what tokens can do, and I'm probably missing a lot of things that those of you watching the video that are familiar with this are thinking, oh man, why aren't you talking about that? But for now, I'll just leave it as that. You know, tokens can represent other things that aren't necessarily like a cryptocurrency, but they can represent other objects. All right, so moving on to types of wallets. Okay, so now we're going to get into the weeds a little bit, and then hopefully I don't lose you guys here. And you see that blue UX dot up there again. I was talking about that in the last video. My background is in user experience. Really, that just entails like how people interact with things like various forms of technology, and making sure that their experience, you know, is good. Like things like usability, stuff like that. You know, the design of things all goes into user experience. And so I put that little dot up there because what I'm talking about now, I feel is an area that could use, you know, good UX folk to come in and kind of help evolve where we are with this, and help kind of pave the way with things. Anyways, I digress. So types of wallets. So as we learned in the previous video, wallets are kind of like your way, wallets hold a private key, I guess is the best way to put it. They can hold one or more private keys, and private keys are what allow you to have access to your assets that are being kept track of on a blockchain system. And so the simplest of wallets, right, is what we will call the paper wallet. And basically it's just a piece of paper that has your private key on it. It doesn't necessarily give you an interface in which you can then access and interact with your funds. It simply holds that private key for you. And so, you know, a use case of this is like people have cryptocurrency and a wallet, you know, maybe it's Bitcoin, maybe it's Ethereum, and they have the private key to that printed out on a piece of paper, and that piece of paper is in the safe, and they're just not going to touch it, right? That's just where it is. They'll bring it out when they need to, and they'll get themselves to a wallet application where they can type that information in, and then that wallet application would get them access to it. Kind of think of the private key as like a safety deposit box key, where like you have a copy and then the bank manager has a copy or has their own version of it. And that would be called a public key. The public key kind of exists on the blockchain system. And so when you come together with that private key, it connects with the public key and it provides you access to the stuff in your safety deposit box. Here, the stuff being kept track of by the blockchain system. Another kind of wallet is what I'll call the full node wallet. Now, a full node wallet is one that is actually keeping a record of the blockchain. So, you know, we talked about the analogy of people keeping track of things on the TARP. When everyone comes to consensus of the changes on the TARP, a photo gets taken of the TARP and everyone gets a copy of that record. And therefore, all it would take for someone to come up and join this is to get their own copy of that those records, that strip of blockchain information. They could join in and help support the TARP and also earn rewards. And so a full node wallet is one that is helping to support the TARP, helping to support the decentralized ledger, which the TARP represents in the aforementioned analogy. And so it will be earning rewards, but it's also holding a full copy of the blockchain. There are also light wallets. And so a light wallet could be a wallet that doesn't hold a full copy of the blockchain, but what it's doing is it's keeping track of everything by kind of keeping in touch with full nodes. I guess is an easy way to put it. Again, technically that might not be exactly how it's working, but instead of having to carry a full copy of the blockchain, it instead pings the nodes that do to kind of keep updated on where things are in terms of the activity that's occurred on the TARP. Again, it requires a private key in order to access the funds or the assets being kept track of on that TARP or on that blockchain system, but it doesn't necessarily have to keep a full copy of the blockchain. Another kind of wallet that you can think of is a hardware wallet. And so hopefully what you're seeing here is the movement of this private key, because that's a key thing to keep in mind here. Is that your ability to access things on this new system, this blockchain system, these world computers, requires that you have a private key. And these private keys are for you and for you only. No one else has it. If you lose it, you lose it. If someone else gets access to it, they can use it to take your stuff. So it's important to keep these things in a safe place. And if you're going to keep it in a digital form, one way to kind of keep it safe is in what's called a hardware wallet. And what you do with a hardware wallet is you connect it to a device that has a wallet application. And what it does is essentially temporarily puts that private key into that wallet application, allowing you to access the funds on the TARP through that wallet application. When you're done, you unplug it, the private key stays in the hardware wallet. It does not stay on the wallet application. And the beauty of this is that a hardware wallet can contain multiple private keys, all relating to different blockchain systems, different world computers. So for example, the one on the far left could be Bitcoin. The one in the middle could be Ethereum. The one on the right could be Litecoin. They are all independent systems. And to have a wallet in any one of those systems requires that you have a private key. And a hardware wallet can contain multiple private keys, allowing you to access your funds on these different systems through one interface. Again, that's why I have the UX up there, because that's what we're dealing with here. How do you design a system? How do you design an interface to allow people to kind of interact with their funds that exist on these different platforms, these different systems? You can also have light wallets that contain multiple private keys in them, right? So this is something that, can also happen. You don't have to have multiple keys in a hardware wallet. You can have a wallet application on a device that contains multiple private keys, again, connecting to different systems. And this can also be the case for mobile wallets, where like you have a wallet application on your phone that contains multiple private keys, allowing you to access and see your funds to different systems. Now, where all of this starts to get really interesting, and this is going to take us back to that role of blockchain diagram that I showed earlier, is this idea of browser-enabled wallets, browser-connected wallets. Browser, like, the browser that you've used to access this video that you're watching, Safari, Explorer, Chrome, Firefox. There's lots of them out there, right? But having browsers that are kind of connected to wallets. Further, having devices that have hardware wallets in them already to help store these private keys in a safe way. So Samsung has already been doing this. They've been releasing phones. I think the Samsung Galaxy 10 maybe has an internal hardware wallet, right? And so by having an internal hardware wallet within the device itself, it helps keep these keys safe. But also in combination with a browser-enabled wallet is going to allow you to very easily access dApps, and we'll get into how that works now. So just to kind of go back over this diagram that I talked about earlier in terms of the role of blockchain, we're going to kind of convert it now to the role of wallets. Again, you have the underlying blockchain system, which keeps track of all this stuff. It's a decentralized system that keeps track of cryptocurrency, tokens, smart contracts, and on the very top layer is the way that you interface with this back-end system. And so if you, as a user, have a device, right, with a hardware wallet in like a wallet connected browser, wallet enabled browser, you are able to access that interface, right? You can go to that interface through your browser. But the difference here is that that interface is connected to a different backend. It's not connected to the backends that we know where like you have to log in, right? We are all so very used to the idea of like when you create an account or you access anything, you log in with like either your email or your personal ID along with the password. In this particular system, that does not exist anymore. Your login credentials are the private key. So when you connect to one of these dApps, instead of logging in with email and password, which the back end or the cloud also has a copy of and says, okay, I recognize it's you. Instead, what happens is you have a private key that connects to the public key and it grants you access to all that information that is tied to it. So on your phone or on your device, right, using a wallet-enabled browser, you can access the dApp and you log into that dApp using your private key. And so that's where this stuff starts to get really, really interesting. You essentially, the way I like to think of it is that you're plugging in. But another way that people talk about is that you're connecting. It's actually kind of a term that you see in dApps now. You connect your wallet. So before I conclude this video, let's talk about some examples of where this could go. And I got a couple examples of things that don't exist yet per se, but you can kind of see where it's going by talking about them. The first one would be this. Let's talk about Airbnb. People use Airbnb to book places to stay when they travel. And through that system, you have to go in, you have to choose when, where you're going to go, when you're going to be there, right? You have to coordinate with the owner to get the keys, to have access, all that stuff. Well, let's think of it like this. What if Airbnb turned itself into a dApp? And you access it via, your device, and you choose when and where you wanna do your thing like you normally would, because the interface would look the same as the interfaces that you use now. The difference is that it's just connected to a different back end. And so you choose, your destination and when you want to go, and you book the place. And let's just say, I know this doesn't actually happen with Airbnbs now, but let's say that you give it a security deposit, right? You put down some money in case you break something while you're there. So in exchange for the security deposit that you pay with cryptocurrency, right? The smart contract gets executed and it sends you a token that represents your access to that place that you're going to. When you arrive there, the place is basically set up with an Internet of Things where you don't have to have keys to enter. You put your phone up to the sensor, right, on the front door. It detects that your wallet contains the token that represents access to the place, and it lets you in, right? It acts as your key. There's no exchanging of physical keys between you and the owner or the real estate person that's in charge of it. I know that I have personal horror stories of like trying to find where the keys are and coordinating with somebody, while on vacation. And I know other people have experienced that too. That doesn't exist here. You don't have to do that. It's all done automatically through these smart contracts. You choose when and where you want to go. You put down your deposit. The smart contract executes, gives you the token, allows you to have access to the place for your duration. Upon the time that is when you're supposed to leave, when you leave, the token, gets either sent back automatically or it gets burnt, like it doesn't really exist anymore. You can't use it to access the place, so you no longer have access. You don't have to send the keys back, and you go on your merry way. Meanwhile, cleaning crew comes into the place, right, and they check everything out. And when they provide the external input to this system, saying, "Hey, yeah, they didn't break anything," you get your safety deposit back, right? It gets sent back to your wallet automatically by the smart contract. So you have no interactions with people. All this stuff gets handled automatically, and you can trust that it will happen because it's being kept track of by this underlying blockchain system. Here's another example. Let's say that you are Farmer John. You grow, corn or wheat or something, and you have crop insurance, right? Like insurance for anything you pay, incrementally over the course of time, every month, every year, however it goes. And in return for that, like if something catastrophic happens, you are able to cash out, right? So Farmer John is using a DApp to pay for his crop insurance, and he pays every month, right? He sends cryptocurrency of some kind to the DApp because he connects to it with his hardware. His wallet-enabled browser, which has access to his cryptocurrency, so he can easily make these transactions. And at some point, a blight occurs and kills off, his crops. Now, normally, what you would have to do is, report this to, a claims adjuster or somebody, within the insurance industry, who would then, decide whether or not you are eligible to receive your payout. But using an oracle or some sort of external input, the smart contract could leverage news that is going on in the world, right? Or something else, some kind of external input that would say, yes, a blight has occurred in Farmer John's area, and it would automatically execute the payout because he had, been paying on time with his insurance, right? So no middlemen whatsoever. It just kind of automatically happens. And again, you can trust that it will happen the way it's supposed to happen because it's being kept track of by an underlying blockchain system. Similar to the Airbnb model, or the example, like suppose that you bought a new car, right? And ownership of that car is represented by a token, right? So a car manufacturer, let's just say, makes 100 cars. Each car comes with a token that is being kept track of on a particular system. When you buy the car, you pay for it with cryptocurrency, and in exchange, you get sent the token that represents your ownership. So your wallet can start having crypto assets in it that start to represent value of different things. And this is what I meant by like our definition, perception of value might change, right? So the title to your vehicle, representation of your ownership of that vehicle could be in the form of a token that is stored by your in your wallet, right? When you walk up to that car, the car uses the Internet of Things to see, hey, yeah, my owner's coming up, right? It's got the token that accesses me, that says that it owns me. And so the door's unlocked, it lets you in and adjusts to the settings that you have, told it to set to, right? When you sell the car, you transfer the token, you send it to somebody else, right? Which goes into their wallet, right? And that way, when they walk up to the car does the same thing, and they can, of course, make adjustments to how the settings are for them. But you get the point, right? All this stuff gets kept track of by this underlying system. There's no need for other entities, other institutions, insurance institutions, accounting firms and stuff like that to keep track of all these records. Instead, you use a world computer to keep track of it for you, a trustless system where you know that it's always going to do what it's supposed to do, and you don't have to worry about middlemen getting in the way. And so that's kind of the role of wallets and where this stuff is kind of going to be going in terms of how dApps should probably start to evolve and start to really change the way that we interact with things. All right, so that's the end of this video, and I hope it was informative. Take care, y'all.